Hello everyone. Let's start our today's topic that are basically numericals of chapter 8, force and laws of motion. And as you know, before starting the numericals, we will first refer the formulas of this chapter. Let's start the formula part. The first formula, that is of a momentum. As you can see, P, momentum, is equals to mass into velocity. Whenever we see an object which has some mass and moving with some velocity, then that particular multiplication of mass and velocity will be called as a physical quantity named as momentum. Means किसी ऑब्जेक्ट का कुछ मास है और कुछ वेलोसिटी से हो जा रहा है तो अपन क्या कहेंगे, वो कुछ मोमेंटम से जा रहा है. Okay, now the momentum can be initial and final depending on the velocities. As it depends on velocity, velocity can also be initial and final. If the velocity is initial, that is u, mass into initial velocity will give us initial momentum. Initially क्या था momentum? Or if the velocity is final, that is final velocity v, then we can say that final momentum as pf. Okay, depending on the situation. if अगर जो initial velocity थी तब का momentum find करना है, we will call it as initial momentum. और final velocity जब थी उस time का आपको momentum find करना है, then it will be called as final momentum. Okay, coming to the next formula, that is F is equals to ma. Okay, we know that comes from the second law of, or you can say special case of second law of motion. But this formula is valid only when there is a single force. If there is only a single force in any of the direction, then it is called as F is equals to ma. But we know that in most of the cases there are multiple forces. So whenever there are multiple forces, what we will do is, or what we have to do is, we have to use the formula of net force. What is this net force? For example, if there is a block, okay, and one force is in this direction, F1. Okay, whenever we see this direction, we have to take that particular direction as positive if you want. Now if there is another force acting in the opposite direction, so while applying Newton's second law, I will not just take the F1 or either F2. I have to take the net force. In this case, what will be the net force? As the direction is opposite. If F1 is positive, opposite direction will be negative. So when there are multiple forces, you have to keep in mind the directions. Then after you can calculate the net force. Basically then you can apply the second law of motion, that is F is equals to ma. Okay. Third is, you can say equations of motion that we have already studied. 3 equations of motion we are going to use in the numerical part of this chapter, and most of the questions, most of the numericals will be solved by using these equations only. As you can see, first equation you can say relates initial velocity, final velocity, acceleration and time. But if you remember, these equations you can only use when there is acceleration constant. For constant acceleration only we can use these 3 equations that you already know. That's how it is already derived. Second equation relates the displacement, you can say initial velocity, acceleration and time. And the last one is relates final velocity, initial velocity, acceleration and displacement. All the 3 equations has its own importance that you will see while solving the numericals. Okay. As you can see, a special case named as law of conservation of momentum. We know that momentum depends on mass and velocity. Whatever the mass with which an object, or whatever the mass that an object have and with what velocity it is moving, that is basically the momentum. Now what does this law of conservation of momentum states? For example, there are 2 balls of different masses. Okay, when you start the observation, at that time they have some velocities. We will call it as initial velocity, because at the start of the observation we will call it as initial velocity. Now whatever the velocity it has, but the velocities are different and they both are moving in the same direction. So there are some chances that they may collide if they are moving in same direction and the velocities are different. Clear? So if the velocity is different, and obviously the one that has more velocity is behind the other and moving in this direction like this, so they may collide. Okay, so before collision, whatever the momentum they have, let's the momentum of one of the balls say m1u1 and another as m2 or m2u2, then after the collision again we will calculate some momentum, we can calculate, but the total of the momentum will be same, m1u1 plus m2u2 is equals to m1v1 plus m2v2. That's what law of conservation of momentum states. Okay, so let's quickly start today's numericals, and I hope you know the rules that a question will be displayed. You have to pause the video, try to understand the question, try to write what is given in the question, what you need to find out, and which formula you will use. If you will be able to do these things, only then for checking the answers you will see the video. Clear? If you have any doubt, if you are not able to understand the question, then also you have to try once. Only then you will start watching the video. The question, the given things are, you can find out what physical quantities are given. For that you have to understand some quick keywords. From that you can find out what is given. Like as you can see, the truck was at rest. What does it mean? Whenever there is a word like rest, stationary, immobile, then what does it mean? That its initial velocity was 0. So you can say initial velocity u is 0. As also it is mentioned, the acceleration is constant. Whatever acceleration it has was constant, its value is not changing. So some things should be strike in your mind. Whenever there is an acceleration constant, the three equations of motion are there for you to use it in the question. As the displacement is 400 meter time, it takes the time of 20 seconds, and if you convert mass into kg, that will become 7000 kilogram. Okay, and what we need to find out? Okay, the acceleration was constant, but what is its magnitude? That we need to find out. And what is the force? You know that from F is equals to ma, if you can find one of the quantity, then you can find the other as mass is given. But before that, how you will find either acceleration or force, or what you will use? As I already told you, acceleration is constant. We can use three equations of motion, but which equation of motion we will use? Think about an equation which connects initial velocity, displacement and time. Okay, so first equation we won't use. In the second equation we have s is equals to ut plus half at square. S, u, t and a. S is there, u, t is also there. We can find the acceleration. But if you want to calculate through third equation, p square minus u square is equals to 2as, then we will need a final velocity which is not given. So we will go with second equation. It says s is equals to ut plus half at square. Okay, s displacement or distance 400 meter, initial velocity 0, time 20 seconds plus half, acceleration we need to calculate, and time again 20 square, that will be 0. You can also write 20 into 20 divided by 2, 2 tens are. Okay, also we can write 200a equals to 400, 0, 0, 0, 0 cancel. 4 by 2 is your acceleration, which means acceleration is 2. We can say acceleration is 2 meter per second square. Acceleration is constant, but the magnitude of acceleration is 2 meter per second square. So with that particular acceleration it will move. Another thing we have to find out is force. Now from second law of motion, F is equals to ma. Just put the values. Mass is 7000 and acceleration is 2 meter per second square. 7 to the 14,000. Unit will be Newton. Whenever you solve a numerical, few things or a few silly mistakes you will try to avoid. That are always, whenever you write the value at the end, what needs to be find out, you will clearly make a box there, so it will be easy for you also and for the one who checks the paper to get the exact answer. Another thing is, never forget to specify the unit, the SI unit of whatever the physical quantity that you have calculated. Okay, so in this question of a frozen lake, the stone of mass 1 kg, when it was thrown, let's try to find out how we can see the given things. One of the person throws the stone on a frozen lake. So whenever it was thrown, the moment he releases the stone has a velocity given, stone of velocity 20 meter per second. Now you know whatever the surface is, because it is thrown in this direction, the velocity has a direction towards that particular direction. Now when it was thrown, after some time it will be in contact with the ground, the stone will be in contact with the ground, and then after some time it will stop. So your final velocity is, that's why, 0 meter per second. Clear? Now when it stops, why it stops? The reason is, whenever two surfaces comes in contact and one of the surface or object surface acts in the opposite direction, then which force is there? Frictional force. Basically the velocity direction and the direction of frictional forces opposite to that. So we can say that the frictional force has this direction, F, force of friction. Okay, as you can see, the motion is in this direction, then the frictional force has a direction opposite to that. Okay, whatever the direction you take, the ball, or you can say the stone, comes to rest after some time, and that is because of some opposing force, and that opposing force in this case is frictional force. Whatever the direction you will take, the opposite direction will be the direction of frictional force. So from this data you can find out, you can see that the final velocity is 0 meter per second, and the direction of frictional force is opposite, and that direction has importance regarding the sign. Okay, we need to find the acceleration first, then we will calculate the force of friction, as you know. And here, if you know that it will comes to rest, means the velocity is changing. Whenever there is velocity change with respect to time, it must have some acceleration, and if the acceleration is constant, only then we can use the Newton's, or you can say, equation of motion. So which equation of motion I will use? Let's try to find out. As initial velocity, final velocity, and displacement is given, and I need to calculate A. Only these things are needed. These we will not use here. Okay, so I hope you know that. We can go with the last, because time is also not given. V square minus u square is equals to 2as, final velocity 0, initial velocity is 20, and its square 2, acceleration we have to calculate, displacement is 50 meter. Okay, before start solving the question, check all the quantities are in their SI units. If yes, then you can go on with the calculation part. If no, then start converting the respective physical quantities into its SI units. Okay, 0 minus 20 square will be, okay, minus will be here, 5 to the 10, 100A. What will be the square of 20? 400. Acceleration will be minus 400 by 100, 0, 0 cancel, you will get minus 4 meter per second. As you can see, the acceleration is negative. That will be the direction of velocity, and this will be the direction of acceleration, as it is opposite to the direction of velocity. That's why it is negative. As you know, again we will use second law, special case, which is F is equals to ma. We have to calculate the force of friction, so we need mass, which is already given 1 kg, and acceleration is minus 4. So the force of friction will also be negative, which is minus 4, and it is Newton. Train mass of the engine is given as 8000 kg. The force by the engine was 40,000 Newton. Force of friction is 5,000. Mass of the wagon, each wagon was 2000 kg, and there are total 5 wagons. Okay, let's try to get a picture so that we can calculate the answer. That is basically the engine part. In total there are 5 wagons. 1, 2, 3, 4 and 5. Okay. Our focus is to determine the directions, as so many things are given in the question. Let's start from the beginning. Mass of the engine. This engine has a mass 8000 kg. Okay. Now that we have used. Mass of the wagon 2000 kg. And total how many wagons are there? 5. So one has 2000, and you can say each has the same mass. If I ask you what will be the total mass of the wagons, you will multiply 2000 with 5. Clear? That is also understood. Force of engine and force of friction. You know that the engine pulls all the wagons of the whole train in particular direction. So the force because of engine will be in one of the direction. If the train is moving this side, basically the force of engine we can take it as this direction, that is 40,000 Newton. Force of engine. And also there is a contact between these wheels and the ground. So when wheels and ground are in contact, you know frictional force will be there, and that frictional force will be in the direction opposite to the direction of motion. Direction of motion is this, so frictional force will act in this direction, and the value is given as force of friction 5000 Newton. Okay. So to calculate the net force, what we will do? We will just add up these two forces. Clear? But the directions are opposite. We cannot add directly. We have to take one of the direction as positive, and the opposite will be automatically become negative. Let's take the direction of engine. Okay. We have taken this direction of engine as positive, and you can see the direction of friction is opposite to the motion, so that will be automatically negative. Let's put the values. Force of engine was force of engine minus force of friction, 40,000 Newton, minus force of friction was 5,000. 40 minus 5, you will get 35,000 Newton. Okay. That was net resulting force. Okay. Now if you remember, we have a formula F is equals to ma. Basically net force is equals to mass into acceleration. From that formula we can calculate the second part, that is F net is equals to mass, total mass into acceleration. Now we are improving or specifying each and every term of the formula. In this formula, every time what we say F is equals to ma. But what is F? F will be the net force, net external force, net resulting force also you can say, net force. Okay, not only a single force we will consider depending on the situation, but mostly net force. Mass will be the total mass, not of any individual part. Okay, as we have to calculate the acceleration as a whole. So the total mass will be of the engine 8000 kg. I will calculate the total mass first. 8000 kg of engine, plus we have 5 wagons, each of 2000 kg. 2000 into 5, we can say 2000 into 5. Okay, what I will get? 5 to the 10 plus 8. I will get 18,000. Unit will be kg. Okay, as all the respective values are in kg. That is our total mass. Now I will use this formula. Net force is equals to total mass into acceleration. Acceleration will be equals to net force upon total mass. Net force we have already calculated 35,000, and total mass is 18,000 kg. So we will coming to the next question, that is of a hockey ball of mass 200 gram. Okay, whenever I see a unit different from SI unit, I will convert it into its SI unit. You know that the SI unit of mass is kg. So what I will write? 200 divided by 1000. So basically in kg. Okay. Now as you can see, the hockey ball was moving in a particular direction with 10 meter per second, 10 meter per second velocity, and then as you can see, it returns. As you can see, a word return means the direction. If initially was this particular direction, then when it returns, it will have a direction this. If I will take this positive, I have to take the final velocity as negative. That is most important part. Now we know what is momentum. Mass into velocity. Mass given, velocities are also given, but we have to calculate the change in momentum. So for that we will first calculate the initial momentum, final momentum, and then change in momentum. That will be final minus initial, or initial minus final, whatever you can take. How I will calculate initial velocity? Mass into initial velocity. Mass is 200 by 1000 into initial velocity was 10. 0, 0, 0, 0, 0, 0 cancel. What I will get? 2. Final velocity will be v. Again, mass 200 by 1000 into velocity minus 5. 0, 0, 0, 0 cancel. 5 2s are 2, 2 cancel. What I will get? Minus 1. Final was minus 1 minus initial momentum was 2. Minus minus plus, but the sign will be minus only, which is minus 3. Change in momentum delta P will be minus 3, and the units are, okay, as you know that the unit of mass is kg, unit of velocity is meter per second. So the unit of momentum or change in momentum will be kg meter per second. Okay, in this question, a bullet of mass 10 gram. Okay. I don't like gram, I wanted kg. Converted kg divided by 1000. Okay, now everything else is in SI unit. Okay, the mass of a bullet which was traveling with a velocity of 150 meter per second in a particular direction, then strike a wooden block or something, you can say, and when it strikes, it travels a bit and then its velocity becomes 0. So what is this distance that it has traveled after colliding with the wooden block? That we need to calculate, and force exerted by the wooden block on the bullet. As you know that when the bullet will strike on the wooden block, it will apply a force. In return, wooden block will also apply a force on bullet. Remember Newton's third law of motion. Every action has equal and opposite reaction. So that reaction of force of wooden block on the bullet we need to calculate. And the time from striking to coming to rest and the velocity is 0 is given as 0.03 seconds. Okay. We have utilized everything. Now to calculate force or displacement, we will start calculation from the displacement. As you can see, we can calculate displacement and the acceleration is constant. We can use equations of motion, but without acceleration I won't be able to find any of this. S is equals to ut plus half at square. I will need acceleration. Other things I have, initial velocity, time, these values I have, but to get the value of s I will need acceleration. From the third equation also, v square minus u square is equals to 2as. There are two variables. To calculate s I will need acceleration. So what I will do is I will try to find the acceleration first. Okay, as you know we can use equation first, that is v is equals to u plus at. Final velocity 0, initial velocity 150 meter per second plus acceleration a, and the time it has taken was 0.03. Take 150 this side, minus 150, and write 0.03 as 3 upon 100. Okay, in the next step what I will do, a will be equals to 150 into 100 divided by 3. 3 5s are 350 is 150. What I will get, minus 5000, and the unit will be meter per second square. So I got the acceleration as minus 5000 meter per second square. Now which equation I will use, second or third? S is equals to ut plus half at square also I can use, and v square minus u square is equals to 2as. I will go with the third equation because I know that the initial final velocity is 0. V square minus u square is equals to 2as. So you can say the calculation will be easier. You can also go with the second equation if you want. V 0 square minus initial velocity 150 square is equals to 2. Acceleration we have just calculated, which was minus 5000 meter per second square, and we need to calculate the s. Minus 150 square. Okay, I will just write 150 into 150 minus as it is equals to minus 2 into 5000 as it is. 0 0 0 0 cancel, minus minus cancel. What I will get, 15 into 15 divided by 2 into 5050. That will be my s. As you can see, we can cancel with 5. 5 3s are 5 10s are 5 2s are 5 3s are. What I will get, 3 3s are 9, 2 2s are 4. I will get the answer of displacement as 9 by 4, or also you can say 2.2 meters. Okay, so we need to calculate the force on the wooden block also. Force on the wooden block will be nothing but mass of the bullet into acceleration. Whatever there will be the action, equal will be the reaction. So we will just calculate the force exerted by bullet on the wooden block. We will get eventually the force exerted by wooden block on the bullet by third equation. The third law of motion. Mass of bullet was 10 by 1000. Acceleration we have calculated minus 5,000. But we will take it as positive. Why? If this is the force of bullet on the wooden block which was negative, then the direction of wooden block, force of wooden block on the bullet will be negative. Cancel these 3 zeros. I will get 5 tens are 50 Newton. Force by wooden block will be 50. The different values are already in SI units. To calculate initial momentum, I will need mass into initial velocity. Mass is 100. Initial velocity is 5. I will get 500. Okay. 500. You have to also mention the SI unit. SI unit of momentum is kg in meter per second. Initial momentum. To get the final momentum, I will need mass and the final velocity. Mass is 100, final velocity is 8 meter per second. I will get 800. So final momentum will be 800 kg meter per second. Another thing is we need to calculate force, which we will calculate by the formula F is equals to ma, correct? But here as you see that acceleration is not given. But also we know that the formula of acceleration from the last chapter was nothing but change in velocity upon time. That is v minus u by t. These are the basics formulas that you have to remember. Mass is 100, final velocity 8, initial velocity 5, and the time was 6. You will get 100 by 6, 8 minus 5, 3, 3 2s are 100 by 2, you will get 50, unit will be Newton. In the next question, the dumbbell falls from the hand. Basically, you have to find the keyword. The keyword is fall. Means the initial velocity, we can take it as 0. Basically, it is a free fall. Mass of the dumbbell 10 kg. The height from which it falls was 80 centimeter. Convert it into meter directly when you see a unit other than its SI unit. Basically, this will be your S only. Okay. Convert this particular distance, displacement or height, whatever you can say in meter. 100 centimeter combines to form 1 meter. So divided by 100, I will get in meter. As you can see, when it falls downwards, its acceleration is 10 meter per second square. Also the velocity, or you can say the motion, is also downward. Acceleration is also downward. Acceleration due to gravity 10 meter per second square, and we take it as constant. So whenever there is acceleration constant, we can use equations of motion. We have to calculate the final velocity and the momentum. From the question, as it says the acceleration is constant, I can go on with the equation of motion. From which formula I can use or I can calculate final momentum, final velocity. Think about first equation, v is equals to u plus at. Time is not given. Second, s is equals to ut plus half at square. Again, time is not given, I cannot calculate v. And no v is present in the second equation itself, yes. Third, which is v square minus u square is equals to 2as. Okay. No time is needed as no time is there in the equation. V square as it is, initial velocity is 0 as it is a free fall. Acceleration, constant acceleration was 10 in the downward direction, and the height, or you can say the displacement here, is 80 by 100. V square is equals to 0 0 cancel, 0 0 cancel, 2 cross 8, only 2 cross 8. V square is equals to 16. Also we can write 4 square. So V is equals to 4. Unit will be meter per second. How will I calculate the momentum? Mass into velocity. Mass given as 10 kg. Velocity is, we have just calculated as 4 meter per second. So our momentum will be 10 4 the 40 kg meter per. Coming to the last question of the video, but before starting the solution, if you have watched the whole video till now, I hope you find it useful, maybe interesting. So don't forget to subscribe, like and share. The last question says the masses are given as 1 kg and the wooden block has a mass 5 kg. Initial velocity of that particular object was 10 meter per second initially, and that particular wooden block was at rest, so its velocity was initially 0 meter. Now the question says they combined, and we have to calculate the combined velocity. Let's try to find out. Whenever these two different objects has velocity 0 and 10 meter, after that they both collide and move with the same velocity. That's why we have to calculate the combined velocity. Means the velocity of the first and second object becomes same, whatever the velocity it has, but the value will be same. Both are moving with the same velocity. After the combination, means there is some collision. If you remember, when there is collision, we will apply law of conservation of momentum. What does it state? Total momentum before collision is equals to total momentum after the collision. So m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Put the values. M1 1 kg initial velocity 10 meter per second plus m2 is 5, and the velocity was wooden block initially was 0. So we will put 0. M1 1 final velocity in both the cases is v, and m2 is 5. Its velocity also we can take it as v. If you want, you can also take any variable you want that we take in maths, like x, y, z, whatever it is. But whatever the value you will take has to be same. जो v1 की वैल्यू होगी, जो v2 की वैल्यू होगी, दोनों सेम है. So we can take whatever the variable as v or whatever the variable you want. Basically this will be 0, 5 zeros are 0, and we will get 10 is equals to v plus 5v. Add it, 5v plus v, you will get 6v. So v will be equals to 10 by 6. So our velocity, combined velocity will be 10 by 6 or 5 by 3 meter per second. Thank you for watching the video. Goodbye.
Physics works.